right, we are live, I think. There we go. Okay, so for the online kids, first thing you need to do is take a picture of this and copy these identities down, okay? Very important that you copy these identities down because you're going to need these identities to do the work. They're also in your book if you want to look for them. And then these identities are the ones we're going to use for today's notes. So let's take a look at today's notes, okay? Today's notes, 5, 17, 21. Our objective is simplifying trig expressions using their identities. Their identities. Okay. And I'll wait for you, okay? So it says, using the identity sheet to simplify the following. So when I look at number 1, I see tangent and cosine. Well, believe it or not, we're going to make this reduce and look simpler, okay? So one of the things I could do is I use my identity sheet, and if I use my identity sheet and I find tangent, what does tangent in my identity sheet say? Sine of cosine, right? So let's rewrite tangent as sine of theta over cosine of theta, okay? So I'm just going to rewrite tangent as that, and then times cosine of theta. Well, cosine of theta over 1, right? Same thing. And then hopefully you can see that I can simplify by canceling the cosines, and then I'm left with just sine of theta. How's that? So it does simplify, right? Kind of cool. Well, I think it's kind of cool. You might not, but I think it's kind of cool. Okay, example 2. Same kind of thing. All right, it needs to be simplified. It might have a much easier answer. So I think I'm just going to FOIL. So I'll multiply first. I'll go this times this times this, right? And then we'll go this times this times this, okay? So I'll just FOIL it. So I'll go 1 times 1 is 1. 1 times a sine of A is just going to be a positive 1 sine of A. And a negative sine of A times 1 is a negative 1 sine of A. Oh, that's going to simplify. And then negative sine of A times sine of A is a negative sine squared of A. And again, put the square there. The square there. It is like quantity squared. And again, I showed the kids here that you got to write it like that because we don't want this because then it looks like it's squaring the angle. What it really is this. Okay, these two are the same thing, but it's easier to write it there. Okay, we got that, right? The square here really means the whole thing squared, not there because that's the angle squared. Okay, now, hopefully you see some things. What do you see? What's the most obvious thing that you see? Spencer, what do you see?
1 sine of A minus sine of A.
Gone, right? And let's see what we've got. So 1, then minus sine squared of A. Now, anytime you see a square, you look to your Pythagorean identities, okay? Anytime you get any kind of a square in there, look for your Pythagorean identity, okay? So I've got a 1 minus sine squared, and I think I've got that right there. What does 1 minus sine squared equal? Cosine squared, right? So I'm going to go ahead and rewrite this as cosine squared of A. How's that for simplifying it? I know I get people just so irritating. They're like, Mr. Davies, how come you didn't answer your phone? I go, well, I'm teaching. Or my friends, Bill, how come you didn't answer your phone? I'm teaching, right? Okay, now number 3. Okay, so let's look at our identity sheet and see if we can see anything, okay? So secant. What do we know about secant? Okay, it's 1 over cosine, right? So let's rewrite this as a 1 over cosine of x, okay? Sine and cosine always leave as sine and cosine, okay? Does that make sense? They're the most basic. Sine and cosine always leave it sine and cosine. Rarely will we change them, rarely. And then tangent, well, what do we know about tangent? Well, tangent on our identity sheet could be rewritten as sine or cosine, right? There's my identity sheet. So I'm going to rewrite my tangent as sine of x over cosine of x. Well, let's see if I can simplify that a little bit. I've got a 1 over cosine of x minus, well, sine times sine is sine squared, but we write it as a sine squared like that. Remember, the square goes inside, sine squared of x over a cosine of x, okay? I don't think I've made it much better yet, but it's going to be. I'm subtracting fractions. Now think of this as subtracting fractions because it really is. I need a common denominator when subtracting fractions. I already have a common denominator, right? My common denominator is cosine of x. Okay. Okay. And so then I have a common denominator of cosine, and then in my denominator I have a 1 minus sine squared. And I think we had that one right above us, didn't we? 1 minus sine squared, right? Didn't we have that above us? So again, it's one of our identities. I mean, 1 minus sine is cosine squared, but we just did this. So then I'm going to have, well, 1 minus sine squared we saw was cosine squared of x over a cosine of x. How am I doing? Doing okay? Cosine cancels with the cosine, right? That one cancels with that one. And it simplifies all the way down to just cosine of x. Kind of cool for a math nerd who likes this stuff. Pretty awesome. What do you think? Not too bad? I promise to help you, okay? Let's look at the back. They're progressing, aren't they? All right. Let's see. Example 4. I think I've seen this in my notes somewhere. Cotangent 90 minus x. Well, if tangent's 90 minus x, then cotangent, I assume, cotangent of 90 minus theta's got equal to a tangent of theta, right? That makes sense to me, doesn't it? So let's rewrite that as a tangent of theta, okay? That's called my co-angle formula. Okay, and then that's times cosine of theta, okay? So I just used my co-function. And now, let's see, what else do we know? What do we know about tangent? Take a look at your formula. What do we know about tangent? Ooh, that's going to help. You see the sine over cosine? Can you see how the cosines will cancel? I'm not getting too far ahead, but you can see that, can't you, Spencer? See, if I rewrite this as sine over cosine, and this is multiplied times a cosine, cancel, cancel, and then I'm left with just a sine of theta. Okay, let's do one more and then I'll help you with your homework, okay? Here we go. Now, I have seen this before. 1 minus sine squared, right? 1 minus sine squared, keep simplifying into that, right? 1 minus sine squared, keep simplifying into this. So what I'd like to do is get this together, but I can't. So what I'm going to have to do is probably get a common denominator, or wait a minute. There might be an easier way to do this. What if I just for a minute change just the tangent? All right, let's see if I can do this. I know tangent, let's see if this is going to be helpful. So tangent's going to be sine over cosine, all right? So then tangent squared would be a sine squared over cosine squared. Okay, so all right, do this in a different color so you can see it. So I'm going to rewrite this as a sine squared of a over a cosine squared of a. So if tangent is equal to sine over cosine, then tangent squared's got to be sine squared over cosine squared. Okay, now how's that going to help you? Well, I'm going to take this fraction here, I know that if I have sine squared A over 1 and I invert multiply, you guys okay with invert multiply, right? Invert multiply, that'd be a cosine squared of A over sine squared of A, okay? All I'm doing is this fraction here. Invert multiply, okay? That's all I'm doing. I think that'll cancel with that, right? So this whole thing would simplify to this. This whole thing here would simplify to just a cosine squared of A, right? I think I've seen that before. 1 minus cosine squared is equal to a sine squared, right? So this whole thing becomes a sine squared. And that is my identity. So homework today is 321, 1 through 10 all, and the extra is 12, okay? And I'll work with you. I want to load up the thumb drive first, but if you guys want to try and see what you can do without me,